So today we're going to cover 4 or 5, the isosceles and equilateral triangles. We are going to be dealing with dates that are not the actual date that you're writing this down, but go ahead and record the dates that are on here. So these are the dates for my white day. Again, these are the dates for my white day. So let's go ahead and get going. Today we're going to talk about isosceles and equilateral triangles. Mostly we'll talk about isosceles because equilateral are usually ones that people do very well on. Isosceles people tend to have a little more trouble understanding. Please understand all an isosceles triangle is. It means that it has two of the sides that are congruent, and if two of the sides are congruent, then the angles at the bottom that are called the base angles are going to be congruent as well. Now, they don't always have to be on the bottom because an isosceles triangle can also be drawn in other directions. So if you see it drawn like this, where these are the two sides that are the same, then your base angles are going to appear at the top. So let's go ahead and label, though, what's on an isosceles triangle. Between the two sides that are marked congruent, and this terminology is going to really show up all year long, so be careful. This is called your vertex angle. Again, vertex angle, you might assume is always going to be at the top, but it's not. Your vertex angle in this picture would be this one right here between these two congruent sides. So therefore, this is your vertex angle. It's whatever angle is between the two congruent sides. Now, the two angles that are congruent, that are opposite those two sides, are going to be called your base angles, and they will always be congruent to each other, base angles. So in this picture you can see this is an isosceles triangle, so these two angles would be congruent. If the sides are congruent, the opposite angles are congruent. That's what the definition of an isosceles triangle says. Okay? It's called an isosceles triangle theorem. If the two sides are the same, then the angles have to be the same that are opposite them. And guys, the vertex angle is always in a specific spot. It's always right here between these two congruent sides. So from there, let's show you some problems that you might see like this. And guys, they're going to be different every time. They're not going to have the same picture over and over and over again. So I can't show you every possible one. You have to apply the information that you're getting. So number one, look at what all it tells you. It tells you so much right here. It tells you DE is congruent to DC. That makes this an isosceles triangle, which makes the base angles congruent to each other. It also tells us that BC is congruent to AC, which makes these base angles congruent to each other as well. It also tells us the measure of angle CDE is 120. Guys, you've got to know where to put that measurement. If you don't know where an angle is on a picture and you need to ask questions about that, ask them one-on-one, because you have got to know where angle CDE is. CDE is this angle that's got its vertex here at D, because that's the middle letter. So the 120 goes here, and the 120 is the vertex angle of an isosceles triangle. To find the other two angles, we would take 180, because every triangle adds up to 180. Subtract the 120, that would leave us 60. But that's 60 for the two congruent angles that are left. But because they're congruent, I can easily just cut this in half, and that would make each of them 30. Because I now know that this angle is 30, by vertical angles, I also know that this angle is 30. Now, again, you may have to turn your paper sideways. I can't turn the picture, but you can on your paper. This is the vertex angle of an isosceles triangle. So I would do 180 minus that 30. That would leave me 150. And 150 divided by 2, if I cut that in half, would mean that each one of those base angles is 75. Which, guys, that's what we're looking for, the measure of angle BAC. We're looking for the angle that has its vertex here at A. So that means the measure of that angle would be 75. Now for the next one, they use the isosceles triangle to actually prove these two triangles congruent. We have a side, an angle, and a reflexive side right here. Congruent to a side, an angle, and that reflexive side. So these two triangles would be congruent. Because of that, their parts by CP would mean that this side is the same as this side. So we would set the 9 equal to the 3x. Very easy math. Divide by 3, and 3 equals x. For the next one, let's look at what they give us. They tell us the measure of angle ABC is 110. So this entire angle right here is 110. But guys, we've already used up part of it right here, this piece of it, as 30 on this one. I can find this angle. I take that whole thing of 110 and I subtract that 30. That means that side of it is going to be 80 degrees. That 80 degrees is a base angle inside of an isosceles triangle. Guys, it's upside down. It is still a base angle. That means this other base angle is also going to be 80. And if these two are 80, I can do a simple equation to find y by adding all of the angles of a triangle up, which, guys, we've done lots and lots of times. 80 plus 80 plus 2y equals 180. Every single triangle adds up to 180, guys, so that we get 160 plus 2y equals 180. If we minus 160 from both sides, that puts us at 2y equals 20. And when I divide both sides by 2, y equals 10. So from there, we're going to go through and talk about it going backwards. So guys, just because we have the fact that the sides make the angles congruent, you can also have it so that the angles will make the sides congruent. It's called the converse. It's going backwards. If the angles are the same, then the sides will be congruent. Alright, so one more time. If the sides are the same, the angles are congruent. If the angles are congruent, then the sides are congruent. It's just going backwards. So we're going to use that idea to apply to these problems where you're going to name the unmarked congruent angles. Well, guys, if they're unmarked congruent angles, you need to look for the congruent sides. Here they are. And look for the parts that are across from them. So those parts in this case will be this angle over here and this angle over here. Now we need to name this angle by 3 letters because there's more than one angle at this vertex. So that would be angle M, L, N. And that would be congruent to angle. Now guys, I could name this by 3 letters, but there's no other angle over here. I can just call it angle N. If you name it M, N, L, that would be correct, but N is perfectly okay because there's no other angle at that spot. Now, when you're naming the unmarked congruent sides, you're looking for the angles that are marked congruent and looking across from them. So I'll switch colors. These are the congruent angles. So the sides that are across from them that aren't marked would be PL would have to be congruent to PM. PL must be congruent to PM. Now, they love this picture on the EOC. This is actually one off their practice problems. You need to understand that they are going to put problems like this on the EOC. They love for things to overlap like this. Guys, this is 3 separate triangles. The angles that are marked right here are on the smallest triangle. So I'm going to pull that triangle out. And it is going to be the triangle where the angles are marked. That's going to be B, A, and R. And so if we're looking for the unmarked congruent sides, that would be inside this triangle because here are your angles that are marked congruent. So across from that would be these 2 sides. And so those 2 sides would be side AR would have to be congruent to BR. So AR would have to be congruent to BR. Now, the next size up triangle is going to be the one that has two sides marked congruent, our medium triangle that has A, B, and Q, and it has the sides marked congruent, therefore you can find the unmarked congruent angles. Look across from there, and that means angle. Now guys, you can't name it by one letter because they're not by themselves, even though when you pull them out they are. There's lots of triangles right there, lots of angles at that point. So make sure you name these by three letters. That would be angle QAB, must be congruent. And if I go QAB, then I've got to go QBA for my other one. Angle QBA. Now, the big triangle, just so we're clear, has absolutely nothing marked congruent on it. Therefore, there's nothing special about that big triangle. There's nothing unmarked. There's nothing marked, period. Therefore, you can't mark anything else congruent in that big triangle. Now, the last thing, which we only have one slide on, but guys, I teach this every year, and every year I have people that still don't get this concept, so please listen to me. Equilateral triangles are extremely, extremely common to see. An equilateral triangle, guys, it means equal sides. That's what equa and lateral means. Equilateral. Now, if they are all the same size, which you can see, they're marked congruent right here, it is also going to be what we call equiangular. Meaning all of the angles are going to be the same. And you can see they're all marked congruent to each other. Again, if all the sides are the same, then all the angles are going to be the same as well. And that makes it kind of unique because every single triangle adds up to 180. And if all three angles are the same and you divide that 180 by 3, then every single time the angles inside of an equilateral triangle will be 60. And no matter what I say, someone's going to be like, they don't give me any measurement on here, and they're going to ask that on the test, and I'm not going to be able to answer this question. Listen to me. If you know it's an equilateral triangle, then the angles have to be 60 degrees, period. The end. You're going to see that on your homework several times. I think the first problem that has that is going to be number 7 on your homework for this. So please be aware, all the angles inside of an equilateral triangle are the same, and they're all 60. So to solve for x, you would just do 6x equals 60, divide by 6, and x would equal 10. To solve for y, it would be 4y minus 2 equals 60. It's always 60. Add 2, 4y is equal to 62. Which when you divide both sides by 4 actually does not come out even. It actually comes out to 15.5. Right? 15.5. Okay guys, so that's your notes on equilateral triangles. Go ahead and get that assignment completed, and I will see you next time.